A herd of wild cattle approaches a river crossing. It has used for generations. On the far bank, one human stands alone, watching. The human is too slow to catch the herd, and too small to stop a charge. No claws, no fangs, no armored hide. Nothing that looks built for a fight. Yet, the lead animal freezes. The entire herd stops moving. Then, the herd turns away before the human takes a single step. From that distance, the human should have been harmless. But distance was about to stop, meaning safety. And the human the herd could see might not have been the real danger. Why would animals stronger and faster than us react before an attack even began? Because humans did not simply become stronger predators. We made the old rules of escape. Unreliable. Scientists cannot ask an extinct wild horse or woolly rhinoceros what it felt. With living animals, fear is inferred from visible behavior rather than private emotion. Researchers look for freezing, sudden vigilance, early flight, avoidance, or activity shifting into safer hours. For extinct animals, the answer has to be more cautious. We combine hunting evidence, ecology, and patterns still visible in animals today. That cannot reveal exact feelings, but it can explain why humans became a serious warning cue. Not every animal responded in the same way. Some may have ignored unfamiliar humans, at least at first. Some charged, defended their young, or stood their ground. Others learned to leave at the earliest signs of human presence. So, afraid does not mean constant, universal terror. It means many animals learned that a human cue could signal a much larger risk. Fear sits on a spectrum, not a switch. To understand why that spectrum shifted, we need to see how fear is built. Every surviving animal is running a quiet risk calculation. It reads shape, smell, sound, direction, speed, and the reactions of nearby animals. No animal can afford to flee from every strange noise or moving shadow. Constant panic would consume energy, feeding time, and rest. Natural selection tunes fear to be useful, not maximal. This is where prey naivete matters. An animal is naive to a predator when it recognizes the threat too late, or uses the wrong defense. Picture a ground-nesting bird that watches the sky for hawks. That same bird may barely react to an upright primate walking calmly toward its nest. Its instincts are not broken. They were shaped for a different kind of danger. Animals can narrow that gap in several ways. An individual can learn from a close call. A group can learn through alarm calls and the reactions of experienced adults. Across generations, selection can favor more cautious individuals. Every pathway depends on survival. The animal, its witnesses, or the cautious individuals that reproduce. Humans became frightening by breaking the rules that once made danger predictable. The first rule to fail was distance. Rule 1. Distance should protect the animal. Most attacking animals carry their effective range on their bodies. Teeth, claws, jaws, venom, or body mass become dangerous within some limit. That gives prey a useful threshold. Watch the threat, keep enough space, and run when it closes in. A thrown or projected weapon pushes that danger threshold outward. A human could remain beyond biting or goring range and still send force across the gap. Once a spear leaves the hand, it no longer needs its owner to win the foot race. At Schöningen in Germany, archaeologists found carefully shaped wooden hunting weapons roughly 300,000 years old. They show that purposeful weapon making existed long before metal entered the picture. Because wood and binding materials decay quickly, the surviving record probably preserves only part of what hunters built. That does not mean every hunt used a thrown spear. Methods likely changed across places, prey, and time periods. But range was only the first surprise. Seeing one hunter did not mean seeing the whole threat. Rule 2. The visible predator should reveal where the danger is. A group of hunters could spread out across an animal's likely escape routes. One person might remain visible, while another waited near a crossing or narrow passage. The animal watching the lone human could not know whether someone else was hidden ahead. Humans did not always need to outrun their prey. They could instead predict where frightened prey was likely to move. Once the route became predictable, the landscape could become part of the hunt. Rule 3. Escape should bring the danger to an end. A river crossing could slow a herd at exactly the wrong moment. A narrow passage could compress a herd into one readable path. Deep mud could reduce the advantage of speed and powerful legs. Fresh snow could preserve a trail after the animal disappeared. Hunters could wait where size or speed mattered less, or guide a herd toward a trusted route. Smoke or flame may sometimes have helped direct movement, but a charcoal layer alone cannot prove deliberate fire setting for a hunt. Even clearing the bottleneck might not end the danger. Humans could reconstruct an animal's route from tracks, disturbed ground, hair, or fresh dung. The prey could vanish from sight, while continuing to leave information behind it. Sustained tracking and endurance may have extended some hunts, though probably not everywhere. Still, humans could stretch danger across distance, hidden allies, and time itself. The deepest problem, however, was not any single technique. It was the ability to change the technique. Rule 4. A defense that worked before should work again. A surviving animal can adjust by fleeing earlier or avoiding a dangerous crossing. Young animals can also copy the caution of experienced adults. Many species learn socially and preserve behavioral traditions. The difference was never learning versus no learning. The difference was how far humans could accumulate and redesign what they learned. A failed hunt could reveal which approach alarmed the herd too early. It could expose which route the animals preferred or which weapon performed poorly. A successful hunt could preserve knowledge of a reliable crossing, useful wind direction, or effective design. One person could demonstrate a technique to others. Others could copy, correct, and combine it with later improvements. Language-rich instruction, physical tools, divided roles, and shared memory worked together. An animal might return next season with the same body and sharper caution. Humans could return with a different point, a different position, and an improved plan. Same species, sharper problem. That capacity made humans unusually dangerous. It never made them untouchable. Ancient humans were also prey, and that deserves real weight. Large carnivores could attack people, contest a carcass, or take over a shelter. An isolated hunter could be killed through bad luck or simple disadvantage. Large herbivores could charge, gore, or crush a hunter who misjudged the moment. An animal defending its young could turn on its pursuers without hesitation. A spear or coordinated plan reduced risk. It never erased hundreds of kilograms of muscle, horn, or teeth. Fear never meant helplessness. An animal could treat humans as dangerous and still fight when escape was blocked. Some animals may even have approached camps for scraps, rodents, warmth, or protection from other predators. That possibility reinforces the main point. Animal behavior is calibrated by cost and benefit, not one universal emotion. Even when no animal died, the expectation of danger could still reshape how it lived. Ecologists call this the landscape of fear. Perceived danger can change where and when animals move, even without an immediate attack. A population may abandon rich feeding ground or avoid water when people are most active. Animals may choose longer routes, remain near cover, or spend more time watching. Playback experiments at South African waterholes found a striking response. Multiple mammal species fled from ordinary recorded human voices faster than from recorded lion roars. That supports a narrow but powerful conclusion. Human cues alone can signal danger without a visible attacker. It does not prove how every prehistoric species behaved. It shows that such a response can occur in living ecosystems. Other research finds wildlife becoming more nocturnal in many landscapes with greater human disturbance. Animals can avoid a predator by changing their schedule, not only their location. A predator reshapes an ecosystem in two ways. It changes the animals it kills and the behavior of those that survive. Fear can alter feeding, movement, water access, competition, rest, and reproduction. The deeper human advantage was never intelligence floating in the abstract. It was the ability to move adaptation outside the body through tools, teaching, shared plans, and memory. A physically unremarkable primate could become ecologically powerful inside that system. Appearance was a poor measure of real power. So, return to the river crossing one final time. Animals were never universally or instantly terrified of ancient humans. Some ignored us, some fought back, and others learned caution through experience, social information, or selection. But 4 old rules kept failing. Distance became unreliable. Once danger could travel beyond the human body. The visible threat became incomplete. Once another hunter could wait unseen. Escape routes could become predictable. And disappearing from view did not always end the pursuit. A defense that worked once could fail. After humans remembered, taught, and redesigned, the river still looks familiar. The human still appears, too far away to strike. The path ahead still seems open, yet the herd turns before an attack begins. We still make a similar mistake when we judge power only by the body standing in front of us. The real advantage may lie in the tools, knowledge, and coordinated system behind it. Animals did not fear ancient humans because our bodies looked unbeatable. They learned caution because distance, escape, and familiar experience no longer guaranteed safety. The frightening thing was never that humans were always stronger. It was that old defenses could become outdated, faster than animals could safely adjust.